Hello everyone. Today I am going to talk about vector database and try to relate the terminologies in vector database for someone coming from the SQL database background or relational database background. So quickly let's jumpstart into the content. But before that, if you like the content of this channel, please like the video and subscribe to the channel. In my previous video, I have shown that how we can use a PDF file to enrich the responses from LLMs. So this way we could use our private data and get LLM involved and get a very good response, and we don't need to personally go and search for the required information. In the process, we had to extract the data from the PDF or other documents, break it into data chunks, and then put it into vector database. So that is where vector database comes into the picture, and today we will be digging deeper into it. So over here, as you can see, first we need to extract the text from a PDF or other documents and split it into data chunks. Then using the embedding models that are also available in Hugging Face, we can create embeddings out of it. Now we will store both the data chunks and the embeddings into the vector DB. And after we store that this data in the vector DB, we will be able to make queries. In vector DB, the data is stored in spatial arrangement. So when you make a query, the query text is actually searched spatially with respect to other keywords or words already stored, which are the data chunks as we are calling it, and the embeddings. So how is it how the database understands that which is the right response to a query? So it is done using distance. So when the query keyword closest to other data chunk embeddings are assumed to be the best response. So the distance is actually measured in 4 different ways: cosine distance, squared Euclidean, L2 squared, and dot product, and Manhattan. So we will see how we can utilize these distances in our codes. Although when we are dealing with PDF and such documents, I personally did not see much difference in the response, but nevertheless vector database are utilized for multiple use cases, for image processing and others, audio processing and all. So in those cases, this can be very crucial. Jumping into the code, it is a very simple code again, as I try to keep things simple. These are the 4 libraries that we need to install, and ChromaDB is the one particularly open source vector database that I have chosen for this demonstration. I will leave this code in my GitHub repo. You can copy it and try it out and make changes and see how the things work out for you. So these are the 4 libraries that you need to install. Then we need to import this particular libraries in our code, and after that, client equals to ChromaDB client. So this line we first need to create a client of the ChromaDB. So this we can assume as similar to create database. So this is our database created client. And then if we say client.list collection, we will see it returns a empty set. After that, we are creating a collection client.create collection, and we are naming it sample collection. And right next to it, we have the metadata, where we are specifying that what will be our distance measurement, distance metric. So right now ChromaDB supports 3. One is L2, one is cosine, another one would be dot product. So these three are supported right now in ChromaDB. So after that, I am putting in the file path which I will use for the query. And over here, this collection that we created, you can assume it something similar to a table in our normal SQL databases. So this is the database and this is the table that we are going to create. So let's quickly go into it. So import libraries imported, table and collection created. So right now, if I go over here and just try to see, so we can see that sample collection, which we can call as a table also, I feel this has been created. Now what we are doing is using the PyPDF2 PDF reader library, we will be extracting the text from the PDF file that we have chosen over here and putting it into a variable text. Let's run it. Done. So next step would be so to now split the text and create the data chunks out of it. We are using recursive character text splitter from LangChain to do it, and we are saying the chunk size will be of 1000. So you can change it accordingly. The volume of the text in each of the data chunk will vary, and yeah, you can see what happens when you query the database based on the chunk size, if there is any difference or not. So we can keep the chunk overlap also from 0 to anything less than 1000. So yeah, let's go ahead. Done. Now what we will do is we will create a document list and an ID list, and we will put each of these chunks into a document list, and we will create an ID list. So if we don't keep this ID list, the system will automatically generate something. Instead, it can be a non-usable character set, which a long one. So instead we are putting in our own ID list. So it will be SNW and I, which is the incremental value we are getting for each of the chunks when we are looping through. That's it. Now this line, okay, I will just add a line over here. This is like insert into table. So this line is basically we are adding the data that we have created, which we have put into the document list and ID list. We are adding it into the table. So this is something like insert into table in our SQL. So that is done. Now we have something. Now the first thing that we try to do is select star from the table. So we have the table which is collection.get and then an empty cell. So that means select star. And you can see all the data that has been, all the data chunks are shown over here, and you can see the IDs against each of the data chunk, which is SN0 and onwards. So over here you can understand 23, which means 24 data chunks are created and stored into the database. Over here embeddings is none, as we have not created any embeddings yet. We will do it later. And the metadatas are also none. And after that we have documents, where you can see that the document starts from here and they are comma separated. So like this, the full document PDF file is stored over here in data chunks. Next, what we will try to do is put in a where clause. So the best way now is with the IDs. With the IDs, we can easily extract a particular data chunk and test whatever we need to do. So select star with a where clause is what we're trying to do over here. So as you see, SNW1, which was, as you can see, feature and third-party tools. So this is 0, this is 1. From the ID, this is 0, this is 1. So let's see if we are getting the right feature and third party tools. So this is the data chunk, particularly from SN1. So that is being done. Now if we want to query the data chunks, all the data chunks, so we want that object type is what we want to know about. So this is the most important thing of vector database, and where the distance things comes into play. So just see over here, till now we have not come across any distance because we did not do any query or the comparison of the query word and the existing data chunks. So now let's see what happens when we execute this. So as soon as you do this, we get first the distance telling us the distance is 0, and we have selected the method of distance calculation as cosine. So this query is what we are trying to find is object type, and we have also mentioned that the text should contain object type. So this is the text that it has returned me, which must be having actually the object type word somewhere over here. Yeah, over here we have the object type. But what happens if we don't keep this where clause? Let's check that out too. We will comment it out and we will close the bracket over here and execute it. So you will see that many data chunks are returned, and you will see that it is not only SN3 now, it is many more. And why is this happening? Because there is close relation with this object type word or the query word that we are using, and that is well captured in these distances. So the more the distance means, which is closer to 1, means it is far away from the query word. So this is the importance of the distance that we talked about earlier. Okay, now the next important thing is how we can delete a record from one of these existing record sets that we have. So let's see if I can delete SN1, which we just checked over here, right? So if I run this, it's very easy. It's like table delete table. So table name dot delete and the ID. So this way, now if I make a query over here, there is nothing. Okay, good. So now we will see what is and how we can do embeddings. So over here, I will create another collection, and I am naming it as sample collection underscore em with the same distance calculation metric, which is cosine, and then we will see what are the collections. Let's create one. Okay, so it is now showing as sample collection em and sample collection. So there are two data. So in the collection database, in the client database, we have now two tables. One is underscore em, another is only sample collection. Now over here, I am just initializing the embedding models. So you can choose any embedding model available on Hugging Face. I am choosing this one. Let's do the initialization. Yeah. And now after this, we have created previously in the above, we did not create any embedding empty list. Right now, we will create an embedding empty list, and over here, we will create the embeddings out of each of the chunks. So we are iterating over the chunks, and we will create embeddings and store them in vector and then eventually into the embedding list. So let's execute this one. Done. So now we will add it into our new collection, which is collection_em. Done. Rest of the process remains same. Let's quickly see. Select star from the table, so it gives me all the data chunks. And this time, don't panic if you see that the embedding is none over here. This is because to improve the performance, it is mentioned in ChromaDB that they don't show the embeddings when we do a get. So nothing to worry about it. But in the query or otherwise, it is being utilized. So this time we will put a query as a string into the query variable, and then we will create an embedding of the query. So this time, as before, object type is my string. We are creating an embedding of it, and then we will utilize this embedding to make the query. So previously it was query_text where we have inserted our object type. This time it is query_embeddings. So yeah, over here, based on our object type, it has again given me these responses and the distances, respective one. So I won't go into the details of exploring the response because it's okay. You can try it out and learn it. So now we will see how we can delete one of the tables from our existing database. So client is our database, and from there we will call the delete collection function, and we will name the table that we want to delete. So let's delete the latest one that we created, or let's not do that. Let's delete the previous one. So that is being done, and now let's see the list of collections. It shows only the latest one being existing. So this is, I think, overall a brief and a quick walkthrough of how we can use VectorDB. I hope it will help you. If you like the video, please like it and subscribe to the channel. That's all for today. Thank you.